Hey there, class. Mrs. Matheson here. We're going to be starting Unit 7, and we are going to start our Notes 1, and it's going to be on the Fundamental Counting Principle. Fundamental Counting Principles has a learning target that says, I can use the Fundamental Counting Principle to determine the number of outcomes for a given situation. So let's talk about, well, Fundamental Counting Principle. Before we get into that, we're going to actually do an example, and then use that to help us with our definition. At a cafeteria, you have several options for a sandwich. You can choose either white or wheat bread. You can choose turkey, ham, or roast beef. You can also choose cheddar, American, or provolone cheese. Construct a tree diagram to represent the number of possibilities for your sandwiches, assuming you select one item from each category. All right, so we're going to start off. We can either have white bread or we can have wheat bread. Then, with each of those, we could choose turkey, we could choose ham, or we could choose roast beef. We also have those options with our wheat bread. Then we have our choice of cheese. So we could do white bread and turkey and American cheese, or cheddar cheese, or provolone. Then with ham, we could do American, cheddar, or provolone. Or with our roast beef, we could do American, cheddar, or provolone. We have those same three options with every meat and choice with our choice of wheat bread. So just listing all those out here, American, cheddar, provolone. So let's talk about what our possible options are. We could have white bread with turkey with American cheese, so white bread with turkey with American cheese. We could have white bread with turkey with cheddar cheese, or we could have white bread with turkey and provolone cheese. So we have three options just with turkey alone. Then we could have white bread with ham and American cheese, ham and American. We'd have white bread with ham and cheddar cheese. We could have white bread with ham with provolone cheese. Or we could have white bread with roast beef and American cheese. We could have white bread with roast beef with cheddar cheese. We could have white bread with roast beef with provolone cheese. So just using white bread alone, we have how many options here? 1, 2, 3, 4, 5, 6, 7, 8, 9. And so we also will have 9 choices with our wheat bread. So we have a total of 18 choices. Okay, so let's talk about, well, what is a tree diagram? It's what we just did. It's a diagram used to show the number of possible outcomes. This is your total number. So this is diagramming out all those options. That's one way we can do some probability, or we can introduce ourselves to the fundamental counting principle. If one event can occur m ways and another event can occur n ways, the total number of possible ways for the two events is m times n. Don't forget to pause the video if you need to. Let's go back and look at the first example here. We have how many choices for bread? We have 2 choices for bread. How many choices for meat? We have 3 choices for meat. And how many choices for cheese? Well, we have 3 choices for cheese. So 2 times 3 times 3, that, if we type that out on our calculator, is going to be 18. That way, I must say, was a little bit faster, for me at least, than drawing out the tree diagram. So, but I might still ask you to do the tree diagram, so be aware we can use both ways. Okay. Farmington High School soccer team has orange, white, and black jerseys. The team uses orange or black pants and black or white shoes. Use the fundamental counting principle to determine the number of uniforms they can wear. All right, so they have orange, white, and black jerseys. So how many choices of jerseys? They have 3. The team uses orange or black pants. So they have 2 choices for pants, and black or white shoes. So they have 2 choices for shoes. So let's go ahead and take 3 times 2, times that by 2 again. So we get a total of 12 outfits for the soccer team. Okay, let's go ahead and take a look at our next problem. You're picking out a new car for your 16th birthday. Woohoo! You have a choice between 7 exterior colors, 8 interior colors, and 4 fabric choices. How many different possibilities of color and fabric choices do you have? All right, I'm going to leave that one up to you guys to do with your fundamental counting principle that we just did. Okay, so let's look at an example with some counting arrangements. It's going to be a little bit different than our last ones. Student council has a president, a vice president, a treasurer, and a secretary. For the school assembly, they were all required to sit in a row upon a stage. In how many different ways can they arrange themselves? Now notice this is a little bit different than our last couple of problems. When we were choosing jerseys and shirts and shoes, it didn't matter if we chose the jersey, then the shoes, then the pants, or if we chose our shoes first, then our pants, then our shirts. It didn't matter the order. But here, we're sitting in an order. So that is going to make a difference. So how many people do we have to start with? 1, 2, 3, 4. So there's going to be 4 spots for them. 1, 2, 3, 4. Now, how many people do we have to choose from for the first spot? Well, you have the president, the vice president, the treasurer, and the secretary. So we have 4 choices for the first spot. Let's say that we put the president in the first spot. Now, in our next spot, we only have 3 choices, the vice president, the secretary, and the treasurer. Then in our next spot, let's say we choose to put the treasurer. And so that was only 2 spots, or 2 to choose from, and then we have 1. So this is, we are going to also multiply 4 times 3 times 2 times 1. So that is going to give us how many ways? 4 times 3 gives me 12, times 2 is 24, times 1 is 24 different ways to sit in that arrangement. Now you'll notice that our number went down and decreasing. It was in order, 4, 3, 2, 1. And actually, that we can simplify by using a factorial. And now it's got an n and then an exclamation point. We actually read that n factorial. It's the product of all of the positive integers beginning with n and counting backwards to 1. So for example, we had 4. Oops, that's kind of hard to see that yellow there. We had 4, and then we went to 3, and then we went to 2, and we went to 1. So we could call that 4 factorial. And that would actually give us our 24. So factorials always are going to multiply and give us down to 1. So find the value of 6 factorial. So we're going to do 6 times 5 times 4 times 3 times 2 times 1. 6 times 5 times 4 times 3 times 2 times 1. Typing that into our calculator. Make sure you don't miss a number. We end up with 720. Okay, the next one asks you to find the value of 8 factorial. I want you guys to do that one on your own. And then when you guys come back to class, I will actually show you a simpler way to do this on our calculator that I'll let you use for the rest of the year. Okay, don't forget to go on and take your Schoology quiz. We'll see you guys then.